Yeah, what's up, beautiful people? Trust you guys are doing good out there. All right, welcome back to your Tech and Engineering. And today, um, I want to really discuss how you can get started in electronics, especially for some of you that are studying physics, electronics, electrical engineering, and the rest. Okay, let me start by saying this. Electronics is very very interesting and very sweet. Okay, it's just that you have to really have the passion, the enthusiasm for it. You understand? Beyond the theories and the rest, you understand? You have to really have the passion for it. You have to have more flair for trying things out. You have to really. That's just the spirit. You understand? It's a very nice course. Must be able to try it out. So today, so what I simply want to do is how you can get started. You understand some of those basic things. I'm trying to just simplify it to the barest minimum of gadget you need to just get started. You don't need tons of dollars and millions and naira, with just roughly 20, 50, 100 bucks, you can get a good gadget and you start. You understand? And you get some few components. Yeah, some components you can just get, then you put them together, you start trying things and you put things together. Mind you, sometimes you try, you fail, you go back. You keep doing it. Like for example, let me show you a board I've been working on. I have a board here which I've been working on for like 2 days right now. You can see the board. I've tried it, it fails. It didn't give me what I want. You can see it. Another version of it, same thing. I've tried. Then I've tried to put it together on this board for like 5, 6 different times. Still yet the same thing. Well, mind you, we are not giving up because it's normal. It's part of those experiments. And once you get it, you become a master of it. So that's it. Things happen. You have to just keep going. So yeah, the basic things I really recommend for you to get so that you can start putting things together and giving it a try at your own convenience. Number one, you need the multimeter. You understand? You need the multimeter. Either one, anyone you have, just try to get one. And I would recommend digital. Well, some people still prefer analog, right? Uh, I'm not against that. It's a very good one also. Just that I like my digital. I like digital stuff. That's it. So either one you know how to you have, just know how to use it very well. Once you are very good at it, you are good to go. And if you are looking for video on how to use it, check my playlist on this channel. I've done tons of video on how to use multimeter ranging from your AC function, your DC function, your current, your frequency range, your continuity test, your ohms or capacitance, transistor test, and so many other various videos that I've done. A lot of them. That is for one of the tools is your multimeter. So you must really know the do and don't of it so you don't enjoy yourself also. So you must really get used to that. Then get a breadboard. You can see the one I have with me here is breadboard. Actually, at first, I'm not a beginner anyway, but I used to use PCB sometimes ago. I'm sorry. No, sorry, not PCB this time. So this is VeruBoard now. This is VeruBoard. Now, VeruBoard is a very good one, but it's just that it's advisable before you put some stuff together when you are not sure if it is going to work or not. You can give it a try on your breadboard here. Do you understand? And that's the way it just really works. Because, for example, like this one that I worked on now, if you look at it, it didn't give me what I want. And for me to remove my component back, now I have to start the soldering. And if the heat is too much in the process of that, I may eventually damage some of this component, but it won't damage anyway. But you understand that is one of the disadvantage when you are not so certain of what you are doing yet. You can see like all these two. This one is a field project. I need to do some modification to rectify it better. Now, so what I'm saying that is assuming it's breadboard now, for example, this one, if there's a mistake here, I can easily pick it up, remove it, change it. You understand? For this now, by the time I troubleshoot and check the issue, now it may be one of these components, maybe the polarity and the rest is what really affected. So I will advise you for a start, get a multimeter, get a breadboard. You understand? A project board, rather, sorry. project board, get it, so that you can really start trying, start doing your trial and error. So once you try one or two things you want, whatever interests you to make, put it together. Once you achieve it, then put it on the board. Then once you put it, you're good to go to make anything. Like for example, what I have here that I'm currently still arranging, not through with it because of my schedule. I have a transistor here. You can see this is a transistor, this is my meter, this is my base, this is my collector. Just pardon if you cannot see. This is my meter coming here to the ground connection of my battery. Why this one is, don't let me confuse you. Then this is my base now. This capacitor is going to my base and is connected to the input. You understand? But don't let me rush you because you're just starting. You understand? So those are just the basic thing I recommend. Get a multimeter, get a breadboard, then get a variable board. Yeah, by the time you want to start putting things together to make it look professional, then you need some component. Like for example, you need 10k resistor. Is a very common one and very useful one. 10k resistor, 100k resistor. You need some diode. You need capacitors. You don't need all these big ones. Just like 16 volt, 10 UF, 1 volt. Just get the various variation of them before you spend $2-3. You can get all these various component I'm saying. And for those in Africa, you can get it more cheaper than that. You understand? So that's just the way it really works. Then start putting things together. Start looking for, you may start with a very basic project. Okay, if this is AC, if I put if I put two diodes together in reverse polarity, the AC will come through one, then the other one will reverse it to DC output before it goes to your capacitor where it's been stabilized, then before it's been amplified. You understand? You begin to try things. So whatever they says in class, you'll be able to understand it better and be able to understand the real practical aspect of it. Let me cite the example. I remember it was maybe 300 level. Yes, there was a course then we were doing. Couldn't remember the topic. Yeah, I remember they were discussing about rectification of circuit here, where you convert AC to DC. Yeah, and the person that was taking the course didn't really do to be sincere, because it wasn't really up to expectation anyway. But one thing really helped me because I know the practical aspect of it. I've tried a lot of things, so I understand. So what I simply did is, since I already know that, okay, once I get a transformer, for example, let's say a 12 volt rectifying circuit now from my transformer. Let me sketch it here so it will be more interactive for you. So from my transformer, let's assume this is my transformer now. The AC is coming, the AC source, then this is coming out from it. You understand now? Then I have my diode here. Let's assume I'm using a 4-leg diode. 4-leg diode, for example. These two will be my AC. Then one will be plus, one will be minus. So this is my DC output now. DC plus, DC minus now, for example. So if this is going out now, this diode has really helped me to rectify it. But if it is not this type of diode, let's assume I'm using the singles diode. Now, two will face the same direction, while the other two will face the other direction too. You understand? So by the time I loop them together, you understand? AC will come through one source, then the DC will go out. But instead of confusing yourself with this part, if you know this pattern, is very good. But if you don't, just use your 4-leg diode. The entire diode is inside just for it to come out. Then from here, so if my AC is coming out, it's DC already, just that how will I put it now? It's not well stabilized yet. It's still flowing. It's still have that a little bit nature of that. You understand? Sinusoidal flow, not in straight direction like that of the CD. DC. So what you simply need to do, get a capacitor. Now, if I'm using a 12 volt transformer, because I'm stepping down to 20 volt to 12 volt, so I need a transformer. I can use a transformer of 16 volt. I can use 20. I can use 25. So what, or a capacitor rather, sorry. So what is it going to do for me is my negative will go to the negative pole of it, while my positive, and remember the positive pole is the one with the longest lag, while the shortest is the negative pole. So from here now, any, I can connect my adapter mat to it, then I can use it for any 12 volt soon device I want to really use it with. You can see this is a project. So there, that was what the exam was on. There was a question there which was just on something like this, 20 mark out of 60. So it was just really fun for me because I understand the practical. So in fact, they were like write extensively. I wrote like almost 5 pages or 6 pages on it because it was as if I'm trying to just pour in the picture I have upstairs, just putting it down, putting diagram, everything, breaking it down. In fact, when the mark the result was I had 96 in it. So that's the electronics can be fun, but it's more fun when you practice the practical aspect of it. So subscribe to this channel if that sounds like something that you really need, because that we'll be doing a lot of projects together, but that has to do with amplification, repair, guitar repair, keyboard repair, amp repair, sound installation, because that's why I specialize on full time, and repair electronics generally. So that really interests you, subscribe to this page, this YouTube group channel, and like this video so that more people get to see full videos like this. Thank you so much. See you guys in the next